Hello, my dear students, a very good morning. And today we will continue the topic kinetic particle theory, and we will understand how it applies and explains the changes of states of matter. So, we continue with the name of God. The learning outcomes for today's lesson is how we will be explaining the interconversion of states of matter in terms of kinetic particle theory. So by the end of today's lecture, you will know how solid changes into liquid and how we can watch it, how we can observe it, and how we can measure it, and how we can deduce the conclusions from the experiment. So here we see the very important concept that should be understood in the very beginning, that all the changes which are going on in states of matter are just due to the difference in kinetic energy. The kinetic particle theory explains us that the particles of matter are in constant motion and they have kinetic energy. So we have to see which state of the matter has the most kinetic energy among its particles and which state has the least kinetic energy among its particles. So I tell you and confirm your concept by revising it that solid is the state in which particles having least kinetic energy, and the gas is the physical state in which particles have the most kinetic energy. Okay, and when we talk about the kinetic energy of liquid state, the kinetic energy of liquid particles are ranging between least, between solid particles, and between highest gas particles. So they are ranging between solid and gases. Okay, so next we think something from the common life, how it happens. Whenever we lick ice cream, it changes from solid to a liquid. So how this changing is happening? This is because of the heat energy which is flowing from your tongue or transferring from your tongue, your body, to the ice cream. So it is the main factor which is responsible for the change of state of matter. And what is that? What is that? What I told you? Yes, this is heat energy. So later we talked about kinetic energy, and now we are talking about heat energy. So how come they are related? I will tell you. Whenever we heat any substance, we provide it with kinetic energy. So this is the main change. So we see what is the effect of heat on the solid state. Do you remember I told you that the particles of solids are very arranged and in organized manner? You see the particles, these are atoms, suppose, and these particles are found in a very defined order in a three-dimensional structure. The particles are so tightly packed together they cannot move. What happens when we heat it? Means when we heat a solid, providing it kinetic energy, what happens? You know, whenever matter is heated, the amount of heat energy is absorbed. So by heating a solid, what change will happen? The particles will absorb heat energy. When heat energy is absorbed or taken in by the solid particles, it will become more energetic and they will start moving randomly. So in this picture you see the particles are moving and they are not that much ordered as they were ordered in the solid state. You see, I select a different color for you. Okay, now you see the particles are moving. They can move, they can slide over one another. So they are turning into liquid. As when we lick the ice cream, it melts. The heat energy is absorbed by the solid. Now we continue that how we can measure it. It is very obvious that when we heat particles, it absorbs energy, and absorbing energy increases the kinetic energy. So we see what is the physical change? The substance changes from solid into a liquid, and we commonly call this process as melting. Like when we put ice in the open, it starts melting and liquefying, it turns into liquid state. So we say ice is melted. So this is a physical change in which particles of ice are absorbing energy and turning into liquid. Now, how we can measure it in the lab or in any industry? So there is a routine apparatus set up by which we can find out the melting point, or the point, or the definite point, or the constant physical property at which every solid melts. And the temperature at which a solid becomes a liquid is called at its melting point. Now we are just very close to the definition that what is melting point. The melting point is the temperature at which a pure solid, I'll tell why I'm writing pure, a pure solid changes to a liquid. Okay, and we often measure it in centigrades. So this is the characteristic or identity of any pure solid. Means every pure solid has its own constant melting point. So how we can measure it? This is the apparatus which is shown here. You can see the diagram in your textbook as well. This is the stand, and this is the heat bath which is filled with water. So we can also call it as water bath. This is the boiling tube. On the clamp, the boiling tube is, okay, you see the water bath. Here is a Bunsen burner used for heating normally in lab. This is the Bunsen burner. You remember it? I taught you in class 6, then we also followed this in class 7, and I showed it to you also. So Bunsen burner is usually the heating apparatus, and the main thing which is thermometer. As we will heat it, the water will absorb energy, it's raising its temperature, and the rising temperature will be shown in this thermometer. Okay, so what is this? This is naphthalene. Have you seen this? The camphor balls? Naphthalene. Okay, the naphthalene is a solid, is having a unique peculiar smell, and it is also called as camphor. It is present in camphor balls, and we put the camphor ball or the naphthalene in this tube. Then we fix the thermometer just right in the above level of the naphthalene. Then we start heating it, and when the naphthalene melting point will come, it will turn into liquid, and we read the level of the thermometer. So this is how we can determine, we can investigate or measure the melting point of naphthalene or any other solid. Okay, so we see what is called as a heating curve. The heating curve is basically a graph. Whenever we perform some experiment, we just very consciously and carefully read the temperature of the change. When change happens, we just read the rising level of thermometer. So this is called as the heating curve, and you will remember that first time I'm telling you, that's why I will go in detail, that heating curve is a graph between temperature and time. when we perform some experiment now, we observe the temperature changes and we plot a graph. You use the graph in the mathematics. So on y-axis you will be putting temperature, and x-axis you will put time, like this is shown here. Okay, now it's your choice that what is your scale, and you observe that what changes are happening. So when you start heating naphthalene, the thermometer starts showing a rise in temperature. So temperature rises to a level, then it remains constant for a while, it never changes. So the stage when the temperature is rising from A to B, now we will discuss it separately. What change is going on between A and B? We will be seeing that temperature of the solid, means naphthalene, is increasing. So first, very obvious change, that temperature is increasing. Okay, then at point B it becomes stationary. So from A to B the temperature is increasing at endpoint B. And what is B? B is the temperature on y-axis showing 80 degrees Celsius. Now we continue heating until point C, and we see that for some time temperature of the thermometer remains constant, it's not changing. So this is the phase when the solid is converting into liquid state, and we call this temperature as the melting point. Okay, now we see what change is going on between B to C. Between B to C, temperature remains same or unchanged, right? Okay, the next thing, the heat energy is constantly absorbed or taken in by the particle. So next thing, very important thing, because the heating is continue, so the heat energy is absorbed during this phase, right? And you see, when you see the sample is a bit mixture of solid and liquid. Now after point C, when we continue heating, the temperature starts rising again. So this is the phase in which we can see that all the solid has melted. During B to C change, you will be seeing a mixture of solid and liquid. But once temperature starts rising again, you will not be able to trace any solid in the tube. And then the temperature starts rising. Why I'm talking so many times the temperature is rising, temperature is constant, and the temperature again rising? Because these changes are observed by the scientist or by the person who is performing these experiments, and so many conclusions are drawn from these observations. So we have studied enough about heating curve of naphthalene. Now we will see what are the other things which can be discussed. As we know that we have to explain the change of melting in terms of kinetic particle theory. So we see we have to explain the process of melting. I'm giving you a question for this now. Melting, explain melting in terms of kinetic particle theory. So here comes your assignments. You have to read the textbook very thoroughly, and you have to revise the concept which I have sequenced in this lesson, just to get a command on these very small reasons and logics, what changes are going on when we are heating a matter, what happens when matter absorbs energy, and in terms of kinetic particle theory, how we can explain it. Just used very good words and simple words to reflect. Okay, I'm leaving you with the hope that you will be waiting for the next video until you get command And if you are new on my channel, please do subscribe it and press the bell icon. It is my request because all the lectures are there, the complete playlist I have made for them, and you can get more concepts from my videos. Thank you very much. God bless you. Allah Hafiz.